Question 11, we're told about two people, Sophie and Kylie, who have both received 1,200 Australian dollars. Sophie's going to invest her money, Kylie's going to buy a car. So we're looking what's going to happen at the end of the 7 years for each of those two people. So start with 1,200, it's increasing, interest rate of 3.4% compounded quarterly. If it's compounding quarterly, that means it's getting paid in 4 times each year, okay, every quarter. Find the future value after 7 years. Future value, interest 3.4% every year, every year, every year. So future value is present value times 1 plus the interest rate over 100 times the number of compounding periods a year, raised to the power of the number of compounding periods times the number of years. So that's on your formula sheet. You've just got to get the numbers in the right place. So future value equals PV, present value, but it starts at $1,200. And 1 plus R is the interest rate, so that's 3.4, divided by 100 times K. Well, if it's quarterly, we're paying it 4 times, so K is 4. And we're raising it to the power of K, which again, quarterly is 4, times the number of years, so times 7. So you're just putting all this into a calculator, which came out as 1,520.92 Australian dollars. Okay, so the bit that some of you were doing wrong here, where you were putting R is equal to 3.4 divided by 100, or you put a 0.0034 or something like that. R is just the rate of interest, 3.4. The dividing by 100 here, it does the percentage bit for you, so don't worry about that. Okay. Anyway, so Sophie's going to have $1,520.92. Kylie, however, she bought a car. If you buy a car, then your money is not going to increase, it's going to decrease, it depreciates. So in terms of the formula, we're assuming that it's depreciating at the same rate each year, this value R. So future value is going to equal to present value. Now instead of being 1 plus, because it's decreasing, it's going to be 1 minus R over 100 times K raised to the power of Kn. Okay? Right. If it's depreciating at R% per year, then K is going to be annually, so K is just 1. Okay? So future value is equal to the present value. Oh, hold on a second, didn't read the question properly. The value of the car, we're actually told that the value of the car we're told is now 669, so we can put that in. 669 equals 1,200, lots of 1 minus R, now that's what we're trying to find, divided by 100 times K, which is just 1, raised to the power of K, which is just 1, times the number of years, which is 7. So we've got to solve this. Now some of you from here went and used nsolve, but you could have done it without. Instead of timesing by 1,200, we can divide by. So if you did 669 divided by 1,200, you would have got 0.5575. And then on this side, we'd be left with 1 minus R over 100 to the power of 7. Instead of raising to the power of 7, to get rid of that, I'd need to take the 7th root. So I need to take the 7th root of 0.5575. So on the right hand side I just get 1 minus R over 100. On this side that came out as 0.919918. And then if I want this to be positive, so I want my R to be positive, I'm going to put it on the other side. R over 100 equals 1 minus 0.919918, which is 0.080028. So then to find R, I'm going to times that by 100. So R is 8.0082. Okay. So the rate of depreciation, it's already using the word depreciation, so we're not going to put minus. The fact that it's depreciating tells us that it's going down. So the rate at which it's going down is just 8.01 to 3 significant figures % per year.